All right, so the first box was these were like the ones that hopefully are like just direct recall. In order to figure out these, I would say you want to make sure that you understand why we're restricting the things that we're restricting to. So remember our unit circle for inverses. So anything that has either the sine -1 or arc sine, because those are both the same things, or cosine -1, arc cosine, and then tan -1, arc tan. For these things, we restrict our unit circle. For sine and tangent, we restrict it to the right side, but we restrict it specifically to the negative angles in the fourth quadrant. So this would be sine and tangent all the way through. But instead of using our natural angles in the fourth quadrant, we use our negative angles. We start at -pi/2, then -pi/3. That was way too far apart, but you get the point. -pi/4, -pi/6. Then we go to 0, and then we go +pi/6, +pi/4, +pi/3, and pi/2. So those are the ones we use for sine and tangent. And then for cosine, we use 0 to pi, so the natural first and second quadrants. So we keep going, we'd get 2pi/3, we get 3pi/4, we get 5pi/6, and we get pi. So if you know those angles and you know the coordinate points at those points, you can either like literally write them all out, or you can know every over 6 is √3/2 and 1/2, and your tan would be √3/3. You can know every over 4 is √2/2 and √2/2, and the tan would be 1. And you can know every over 3 is 1/2 √3/2, and the tan is √3. So that makes your cosine the first ones. It makes your sine the second ones. And it makes your tangents the ones we wrote at the end. And then all you have to worry about is the positive negative signs as you move through. So my advice again is to be able to do that like quickly without thinking too much. Like at this point, we've done this a couple of times, maybe not the negative angles until Friday, but hopefully if you did the homework, like this is something you would be able to do. Then if you know that stuff, so like the front loading part of it, I would say is the work, because now it should be instant recall. So as you go through each of these, for example, A, sine -1 of 1/2, I'm looking for where my y would be 1/2, which is at an over 6, and because it's positive, it's in the first quadrant. If that's at -1/2, now I'd be at -pi/6, because that's what quadrant I would use for sine and cosine. So you will get, I think there's one question on the quiz where it's just like that, like root memorization from that stuff. And then there's one, which you'll see it on the quiz review, but then there's one, like the ones that were on the circuit where you had to do 2 parts, like it would say cosine of arc, sine, something like that. Like those, you'll get a question like that, where you got to work inside, most outside. Then you had your inverse ones based on your graphs. So this is, I would say, yeah, on Friday I said you could kind of either know your original graph and then switch it, or you could just go directly to your inverse functions, which is probably where I would suggest you are at by now.
For that one, wouldn't the last two be switched?
Yeah, it's CAB.
Oh, did I write that wrong? This is A, and this is, because that's cosine. That's definitely sine, and that's cosine. Yeah. That's CAB. Thank you. And you would want to know, so this is your sine. Sine is the one that passes through the origin. Sine and cosine shape is similar, but the sine passes through the origin, it increases, and the cosine is the other direction. It decreases, and it passes through pi/2. If you think about these on as far as your curves go, okay, if you don't know how to graph these, go back to your parent function and then shift your x and y's. But hopefully, if you just memorized these, I think it will make your life a lot easier. And then if you know what they look like, you should be able to do the domain and range. So it's on your quiz review to draw them out and to give the domain and range. There's not going to be a direct question on your quiz that says draw sine -1. These are all negative ones. Cosine -1 and tan -1. But if it were me, I would give myself a little reference at the top of those questions, like draw those out. So then if I'm doing domain and range here, let's start with sine. Domain is your x values. So you're going from -1 to +1, which is consistent with the range on the parent function. Then the range is from -π/2 to +π/2, which again is consistent with the range or with the domain on the parent function of sine. Cosine, the domain goes -1 to +1, same domain. Range goes 0 to pi, which is what we restrict cosine to. And then tangent, domain, these are arrows, so these are your all real numbers, or -infinity to +infinity. And the range, it goes -π/2 to +π/2, but it doesn't touch those because that's where asymptotes are, so it gets parentheses. That's the only difference between the range on sine and tangent. We restrict them the same, but at π/2 and -π/2, tangent is undefined, so there's actually horizontal asymptotes happening in those two spots. God bless you. So now if you understand those things, then after you do the transformations on something like 3a and 3b, now you can alter your domain and range. So on A, the 2 on the front is a vertical dilation by a factor of 2. And a vertical dilation is going to impact your range because it impacts your y's. And you would take your range and you would multiply it times 2. Then the pi is a vertical shift up to, it again impacts your range because it's a vertical shift. So after we stretch or shrink, then you move. So remember when we went way back to when we did transformations, and I said, think about when you wake up in the morning, you want to stretch before you get out of bed. So you want to do the same thing. You want to move and stretch before you get up and shift up or down. Okay, so that goes for both horizontal and vertical. Stretch, then move. On this one, there was no change to the horizontal, so my domain stayed the same, but the range, again, we doubled its length, or we doubled the x values, and then we added pi to each of them. Questions on that one? All right, so then cosine -1, try that again. So over, good morning. Okay, so the over the y would flip this side to side. So it goes like this. Nope, and I did it again. Over the x would flip it. Okay, now go to 4. 4 says the function f is defined by, and it gives you the function where -π, it goes from -π to pi. Find the inverse f -1 of x and the domain of the inverse function. So we're switching the x and y. I think that part we're good on, right? The switching the x and y, the solving for the new y. Do we feel confident on that part? Yes. And then understanding the change to the domain. So once you get your inverse function, then you have to think about what alters my domain. We just said it. Anything that alters your x value alters your domain. The things that alter your x value are your b and your c, right? So we look at what's happening inside the parentheses. Inside these parentheses, there is a factor of horizontal dilation by a factor of 4 because it's the reciprocal of what's on the front of the x. And then there's a shift to the right 4. So I take my domain, which is -1 to 1. So if I I obviously need to memorize them for all 3, but sine is the same as cosine. They're both -1 to 1. And I know I take that and I stretch it and then add it. So I multiply it by 4 and I get -4 to 4, and then I add the 4. Oh, I actually did the other way around. I think you get the same answer both ways this time. If you take your -1, 1. No, I didn't. So if I did 2 sine -1, it would be 1/4 x minus 1. And then obviously if there was a vertical shift, it'd be here. So then your 1/4 is your stretch, factor by 4. And then your -1 is your shift right 1. Yeah, you can keep them separate. Then this was your added practice. So again, like I said before, you're going to get one where it's just a single factor like these. There's one question like that. And then there's one question where it's the two-part where you have to first find what's happening inside the parentheses and then do whatever's on the outside. Yeah. 10. Because it also goes back to the tangent stuff from 3.8.
Wait, can we go back up to the domain?
So here's what I would recommend as far as your unit circle goes. When you're dealing with your inverses, I would try to draw out, at least map a little bit, your range, right? We talked on Friday that sine and tangent are the right-hand side of your graph. The original first quadrant, which is your pi over 6, your pi over 4, and your pi over 3. But then in the fourth quadrant, instead of using our natural angles, we use the negatives. So negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. And then pi over 2 would be at the top. So those are for sine and tangent. So, well, this one's cosine. Then the top from 0 to pi is cosine. And you use all the natural angles there. So I would go pi over, or 2 pi over 3, 5 pi over 4, 7 pi over 6, and pi. And then, honestly, I don't know if I'd even take the time to add all the coordinate points. I would, like, maybe off to the side, if it were me, I would say, okay, all my over 6s are root 3 over 2, and 1/2, and the tangent is root 3 over 3. All the over 4s are root 2 over 2, root 2 over 2, and the tangent is 1, and all the over 3s are 1/2, and root 3 over 2, and the tangents are root 3. And then, you know, your sines are all the, or cosines are all the x values. Your sines are all the y values. And then your tangents are the ones we added on. That's like your, you know, like if you're taking a test or something in English and you get a word bank. That's it. Those are your answers. You just have to figure out which one it is. Okay? They can't be anything other than those positive or negative of those versions and then your quadrant angles, but it has to be one of those. So if you wanted to add on your 1, 0, 0, 1, negative 1, 0, and 0, negative 1, now you really have them all. So for this question, it says find cosine negative 1 of negative 1/2. So if I do that, I know it's cosine being 1/2 means that it's an over 3. Cosine is negative in the second quadrant. The over 3 in the second quadrant is 2 pi over 3. Any other question from this page? Oh, it's sine. So sine is 1/2 at the coordinate point root 3 over 2 and 1/2, which is your over 6. And if it's negative, we're looking in the fourth quadrant, but we use the negative angles for sine. So it'd be negative pi over 6. It's here. Valeska.
But isn't that angle like 11?
Yeah, but you can't use it because it's an inverse. In the inverse, you have to restrict from negative pi over 2 to positive pi over 2.
Okay.
Yep.
Can you repeat that?
Mm-hmm. So sine and tangent, the parts of the graphs we take, can't be chunked. It has to be consecutive. So when we restrict from negative pi over 2 to positive pi over 2 on sine, our curve looks like this, right? If you go pi, 3 pi over 2, and 2 pi over 2 pi, the fourth quadrant is here and is here. So my curve does continue there, but I can't ignore all this and say, take this part of the graph and this part of the graph. It has to be fluid. So that's why we go from negative pi over 2 to positive pi over 2. You get positive and negative values for sine, and it's one fluid part that would pass your horizontal line test. So this time they reversed it like the one that were doing before. We did the inverse on the inside and then the regular on the outside. They just reversed it. So you have to find the tangent at 5 pi over 4. At 5 pi over 4, tangent's 1. And then you're doing the sine negative 1 of 1, which happens at pi over 2. So always go inside first, inside the parentheses, and then work your way out. Oh, sorry. Okay, then the second page of your circuit, if again, top to bottom, left to right, the top one is 0 and root 3 over 2. Then negative pi over 3 and pi over 2. Then pi over 4 and root 2 over 2. Then negative pi over 4 and negative pi over 2. And then 5 pi over 6 and pi. Questions on any of those?
And these answers are.
Yeah, they should have been available this morning.
The tangent at pi over 1.
So tangent at 5 pi over 4, this one, you work inside. All right, so the beginning 1 through 6 is all 3 8. This is all 3 8, okay? And again, kind of like rote memorization at the beginning. This is not restricted. This is all the way around your unit circle, and it's going to give you the angle, and you have to give me the tangent. So if you understand your denominators, and then you know all students take calculus, those should be easy questions. For 4, it's giving you the coordinate point at the terminal ray, and it says to find the slope of the terminal ray. That's the same thing as the tangent. Slope of terminal ray is the same thing as the tangent. So we do y over x here. Again, that should be a relatively easy question. And then 5 and 6 are where you start to graph it. So I'm going to go over an example for 5 and 6 if you want to either add a page to the bottom of your note or something, but let's go. We're going to review the graphing. Any questions before I get to that? So are we good on 1, 2, 3, and 4?
What does that university have next to
Say that again.
the 3 and 8?
This is section 3.8. Yeah. So when we're graphing tangent, okay, remember that your A is that quarter point and the 3/4 point. So this is at your quarter and 3/4 point. That's how high and low that quarter point and the 3/4 point go. If it's positive at the front, then my shape is up, right, and down, left. If it's negative on the front, then it's up, left, and down, right. The B impacts your period. So we do period equals pi over B for tangent. The B and the C both impact your horizontal and your vertical shift. If I'm describing it, then this is my horizontal shift. And this is my horizontal dilation by factor of 1 over B. And A would be my vertical dilation by A. Inside the parentheses, remember we go the opposite direction. So if it's a positive, if it says x minus something, then we go to the right. If it's x plus something, then we go to the left. And then D is your vertical shift. We're going to kind of, like it'll say, like describe your transformations. You can describe all that, but then it's going to ask you to graph it. And to graph it, you need your asymptotes. So to find your asymptote, we set bx minus c equal to pi over 2. That gives you the middle asymptote. And then you subtract from that minus the period. So you subtract the period. And then you subtract or add to it the period. And that gives you 3 asymptotes. You plot your 3 asymptotes. You find the middle point. You eyeball your quarter point, your 3/4 point, and you go up and down your A. So it'd be here and here and here and here, and then you'd draw your curve. And then at the end, if there's a vertical shift, we would shift it up or down. All right, pick fraction or whole number. Fraction. Give me a fraction between 0 and 1. 1/2. So 1/2 tan. Give me a number between 0 and 5. 3. Give me a number between -5 and +5. Huh?
0.
You tried the 0. Good try. Now give me a number in pi form. Well, no, I'll keep going. So give me a number between -5 and +5.
4.
Okay, that way I don't come up with any question that's already on your quiz, because that's how my brain usually works. Okay, now we're going to actually work this out. So I'm going to change this to pi, otherwise it gets weird, but we're going to work it out. So what's the 1/2 on the front affecting? Vert dilation, factor of? 1/2. What's the 3 doing? Horizontal dilation, factor of 1/3. What's the minus pi doing? Right pi. And what's the +4 doing? Up 4. Okay, now we find our period. Period is pi over b. So pi over 3. Then we find our middle asymptote. So we take this whole thing, whatever's next to tangent, and we set it equal to pi over b. Sorry, a pi over 2. Because that's pi over 2 is where your original asymptote is for tangent. Well, one of them, but from your parent function. And so now we let the shifts happen by solving for it. We could also say take pi over 2, find a factor of 1/3, and then shift it to the right pi if you had it visually. But in my opinion, it's going to be easier to do that algebraically with this. So I can either distribute that 3 in, or I could divide by it first. So divide by 3 or multiply by 1/3 here, and I get x minus pi equals pi over 6. And then add pi. And I'd get x equals, this would be 7 pi over, or 6 pi over 6. Over, plus pi over 6, which is 7 pi over 6. That's your middle asymptote. Dane.
It gives us horizontal shift by like the period, and we have to change to that as well.
If it was the exact period, no.
Like if it said instead of pi, if the horizontal shift was pi over 3, then can we just keep the graph?
Sure. So then from here, I'm going to subtract the period, which was pi over 3. And then on the other side, I'm going to add the period. So an over 3 and an over 6, I'm going to have to multiply by 2 here. 7 pi over 6 minus 2 pi over 6 is 5 pi over 6. That's going to be the first asymptote as I move from left to right. That 7 pi over 6 is the middle asymptote as I move from left to right. And then times 2 and 2, 7 pi over 6 plus 2 pi over 6, and I get 9 pi over 6, which is 3 pi over 2. And that's your third asymptote. Then I would find this. There's two ways to do this. Either plot your initial and then shift it up or down, or try to do both of those in your head at once. My advice is plot your initial and then shift it up or down. But if you want to try to do both at once, it's okay too, okay? Sometimes it's more complicated than others. If I'm plotting first, then I'm going to find the middle point here, and I'm going to eyeball the 1/4 and 3/4. And my A, so if this is 1, then my A is 1/2. Then I'm going up and down only that negative 1/2. So I go down first, it's here. I go up first, I go up second, down first, up first. And this would be before the vertical shift. Then the last thing I do is take that vertical shift, which is up 4. So I go from 0 up to 4, 1, 2, 3, 4. That's my middle point, I go down from there 1/2 and up from there 1/2, down from there 1/2 and up from there 1/2. And that's your shifted one. You do not need the first one and then that one. You could do both at once. As long as you understand what you're doing. You're shifting up 4 and then your quarter is at negative, so, or is at 1/2. So I go down 1/2 and up 1/2. Yeah, Amira.
When we're doing like the quarter points, can we eyeball it?
Yeah, you can. Well, you could literally eyeball your halfway point and your quarter point. Like, I don't need exact values. What I'm looking for work-wise, 1, it's going to ask you to describe your transformation. So that's going to be part of it. 2, it's going to ask you to graph it. And on your graph, I need to at least see your asymptotes marked. Beyond that, like obviously your asymptotes, and then I should be able to see your Y value. If you change the scale, then I need to see that done. But if not, then you should be able to plot the other stuff.
On the quiz review, number 5,
Actual just graph sine -1, tangent -1, or cosine -1 are not straight up quiz questions, but if you don't understand those and the domain and the range, it's going to make the rest harder. So my advice is make sure you have that memorized, okay? Vertical dilation, factor of 4. The half. Horizontal dilation, factor of 2. Minus pi, right pi, plus 3, up 3. Okay, so that's describing the transformations, which I think the directions say, describe the transformations of the function, then graph 2 full periods of the function. So after you describe all of that, then we find the period, which is pi over b. So pi over 1/2 is going to be 2 pi. That's the period. And then I find my asymptote by taking everything that's next to tan, not added or subtracted with the vertical stuff, but everything next to it, and setting it equal to pi over 2. So 1/2 x minus pi equals pi over 2. And I want to solve for x. You could distribute, but then you're just going to have to divide by it anyway, so you might as well just get rid of this. To get rid of that, good. And I get x minus pi equals pi. And then I add the pi, and I get x equals 2 pi. So my middle asymptote is at 2 pi. Now from the one on the left, from that one I'm going to subtract to get the one on the left. So I subtract the period, which is 2 pi. And I get x equals 0. And I add the period. And I get x equals 4 pi. Huh? I'm making it right now. Yep. And I did another example before this with like a period. They gave me all the different numbers, and I came up with one with them too.
What was the period?
The period is 2 pi.
So wait, then you said the
Rodrigo. Like, I'm going to now put all these on an axis. The first one you find is in the middle as I go from left to right. Because I have 0, then I have 2 pi, then I have 4 pi. So from left to right visually, the first one you find is the middle.
where would that go? The 2 pi?
Yep. And then there's my asymptotes. Yeah. I hear you. All right, now I want to find, I'm going to find the point in the middle. I'm going to do the vertical shift at the end. Okay? You could either build it in now or you could do it at the end, but I'm going to find the curve and then I'm going to do the vertical shift. So I just have to eyeball it. I don't need it to be perfect. That middle point, my A is 4, but it's negative. So I would start up at the quarter point at 1, 2, 3, 4. And I go down on the quarter point on the right. So without the vertical shift, this is what my graph looks like. And then with the vertical shift, which was up 3, I'm going to take all those points and I'm gonna shift them up 3 places. So 1, 2, 3, it's gonna go all the way up here. This one's gonna come up here. This one's gonna come here, and my graph literally shifts up 3.
How many of these type of questions?
There's 2, but all those things are split between those 2. Like you're not getting one with a reflection, a vertical shift, like not all of it. You're gonna get 2, maybe one has the shift and a stretch, and one has a horizontal compression and a, like that kind of thing.
And is that the only graph is like this?
Yeah, well, your inverse.
Okay.
Yeah.